So this week we're going to cover Unit 8, which mostly focuses on subnetting. Network Plus asks some subnet questions, but not too intense compared to CCNA. So we want to be able to understand mostly for practical reason. It's important that you do this because even in cybersecurity, you kind of have to understand how to segment your network, and a lot of it has to do with IPv4 subnetting. In IPv6, there is a way that we can actually divide up the subnet or the network into subnets, but a lot of the times it's not much needed. And most companies haven't fully transitioned to IPv6. So what we'll see is we are going to focus only on IPv4 today. So subnetting is a way that we can utilize an IP address to create a range of other addresses that would allow us to create smaller subnetworks within our local area network, our LAN. And so we can design a network that would have many subnets in multiple locations. So for example, if you're looking at companies that have branches in like the geolocation, in the same geolocation, but we would have different offices. So for example, like if we take Bank of America, for example, they might have branches in Riverside, a few branches in Moreno Valley, and then other locations in the city nearby. So we can use subnet that way. We can also use subnet to really allow us to reduce some network traffic by separating the traffic into different areas. And we would use a multi-layer switch or a layer 4 switch to do this. We a lot of times use subnet to be able to create or utilize the ranges for virtual local area network or your VLAN, and that's important, okay? So it allows us to be able to implement a range of IP addresses by using some of the host bits. As you know, in an IP address, you would have network ID and host ID. Depending on the class of IP address that you're using, we would be able to utilize or borrow some of the bits into specific area. And like we would borrow into the network bits, so that way we would have more of a larger scale network. And this is why IPv4 is mostly using this, is because IPv4 is limited to 32 bits versus IPv6 is 128 bits. So in an enterprise environment, you might face issue that you are running out of IP addresses in the class that you're using. So let's say that you started as a small company, you use a specific IP address, and eventually you scale to a very large company because now you have data center and endpoint devices, and you need to accommodate that. So subnetting is allowing us to be able to scale, right, without changing our IP address completely. So the first question asks you to describe the purpose and the benefits of subnetting. We can say that we can take an IP address range and we can divide it, right, into multiple address ranges. So we can start with one set of IP addresses, and we would take that and be able to expand it to multiple groups of IP addresses. And so that way we can have larger networks. So within our local area network, we will have sub-networks, right? Maybe for branch offices, like what we talked about. Maybe for virtual local area network of VLANs, like what I have mentioned. And so in a geolocation, if you're looking at different sites, subnetting is ideal. It allows you to really focus on, when you're troubleshooting, which part of the network is having issues, right? So if we're not using subnetting, that can be tedious for us to go through and troubleshoot. But when you troubleshoot, you said, okay, this is a subnet, right? This particular subnet is having outages issues, so we would know. It also allows us to be able to diversify our network bandwidth, so we can route our traffic in a specific way where it's not going exactly through the backbone. Everything can be filtered and monitored back to the backbone, but we want to be able to divide up our network so that way not everything is traveling down the same path, right? So you might have different departments that require different subnets. You might have different locations that require different subnets, like stores, if you're looking at retailers or even restaurants. And we would implement the network through using a multi-layer switch or layer 4 switch. So we would start with the IP address, let's say. So before we do number 2, you can refer to the first page for the answer for 1. All of that should be there verbatim. Any question regarding the purpose of IP subnet? So before we do this, let's talk a little bit about the steps in subnetting. So you have to really ask yourself, as let's say you're a network engineer or administrator, how many subnets do you really need? And that's going to help you determine how you're going to be able to use the bits, okay? So let's say right now we only have one network and we want to be able to expand it so that way we would have 8 subnetworks, right? Maybe we are growing as a company. So here it talks about the steps for subnet. So first, you need to determine the number of host bits required for the desired subnet. So the second question that you need to ask yourself after you ask, how many subnets do I need? How many hosts do I need in each subnet? Okay, so why do I care about that? Each IP address belongs to a system. So let's say that in one subnet, I would need, let's say, 1,000 IP addresses for my endpoint devices, right? So the 2 questions really going to help you go through, and you would be able to set up your exponential for your base 2. As we learned in the prior weeks that computer understand binary, so your base is always going to be the 2, right? There's only 2 numbers, 0 or 1. And in order to determine the number of subnets, you would, determine the number of mask bits, that's going to give you the number of subnets. So for example, if I need 4 subnetworks, right? I ask myself what the exponent, the n would be. 2 to the power of n is equal to 4. So what is n, right? So for those of you who took pre-cal or other math classes, you can do natural log of that. But so I would need to really ask myself, how can I calculate the number of subnets using 2 to the power of n, right? The n is going to represent the mask bits. So if I need 4 subnets, I would know that 2 to the 2nd power is going to give me 4. If I need 8 subnets, it's 2 to the 3rd power. So ultimately, you would have what's called 2, right? 2, and you would raise that to the power of n. And the nth value, right, is going to be the number of mask bits. That's what you see in step A there, okay? So this nth value, the exponent is going to help you determine the number of mask bits, which gives you the number of subnets. Now, the second step is that we need to convert the mask into a binary. This is why we spent a couple of weeks, right, talking about binary to decimal conversion, because IPv4 is represented in decimal as 32 bits. So the number 10 needs to be converted into a binary so that way the computer would see. So if you're given an address, this is a class A and this is a common address that you see, 10.0.0.0. So when you look at this address, you know that it is a network address because where my cursor is, your host bit doesn't end with a 1 or 254, right? It starts with a 0 here, so that's usually an IP address for the router. It's like having a zip, and then the subnet mask is a zip code, right? So it kind of narrowed down the network where you are, okay? So if you're given this IP address 10.0.0.0, and you need to be able to determine how I can expand this into subnets. So first, for step 2, you would look at the subnet mask and say, this is a class A address by default, right? Which gives me a network, and the rest are the host ID, network, host. How can I tell? Because of the subnet mask, okay? The 255 represents the network ID, and the zeros here represent the host ID, okay? The reason why we convert this into binary is that we want to be able to borrow some of the bits from here and pull that into here, so that way we can scale out. So as you know, class A has a tremendous amount of hosts, but in some enterprise, that's not enough, right? If you're looking at something like Amazon or companies that have huge data center and many endpoint devices, we are going to have to subnet, okay? So when I convert my 255.0.0.0, I would have all ones here, because we did this before. When you have 255, all the bits are on. And for the network, the host ID, all of those are 0. Okay, are you with me so far? Yes, no? Not sure. Okay, so the subnet mask in binary is represented like this. Now, what I need to do is, from my example, I need to borrow 2 bits, right? I need to borrow 2 bits and place it here, so that way I can have 4 additional subnetwork, okay? So, because ultimately the problem tells me that I need to calculate for 4 additional subnets, and I would say 2 to the power of n is equal to 4. So the mask bit is going to be 2. So these 2 bits are going to be borrowed. And as you notice in the previous, when we don't borrow, they are 0. And when we borrow, they become 1s. And it's simply that, right? Okay, and then you plug this value into your programmer calculator, you will be able to have your network ID here. Okay, so we will borrow the 2 bits from the host, and then when we convert it, right? If you convert it back into the decimal, you know that the front is going to be 255. We already know that. But the second ID for your subnet mask, it is 192, right? If you don't believe me, take the 1 and the rest of the 0, put it into your programmer calculator as binary, and click decimal, and you would have 192. So when we created the subnet, this is going to be your new subnet mask. Understand? So basically, it is a way that we can manipulate the subnet mask to be able to yield us additional subnetworks within our network. Okay. Any question? All right. Now let's take a look at the exercise. Okay. You have to be with me here. If you get confused, stop me and ask questions, because this is a high-level concept, right? I had to learn subnet mask several times. It's not something that like one pass is going to get it. You have to practice this, right? And so some people, right, super smart, they'll get it just like that. Right? For me, I just needed to practice it. So what I did was I represented in a way that you can visualize it as you go step by step, okay? So let's say that this is your company's IP address, 172.14.0.0. This is the IP that you start with. And we know that by looking at the IP address, this is a class B, IPv4, right? Also, the subnet mask is given to you. It's 255.255.0.0 here. So it is a default class B right now. Okay. So based on that, I would need to identify how many network octet, right? And how many host octets. So I have network, host, host. Why? Because each of the 255 represents the network ID, right? The second part, network ID, and the third is the host, which is the 0, and the next is a 0, which is a host. This is a default class B. Then I would take that value, the subnet mask that's given by default class B, and I would convert it all into ones and zero, right? Okay. So before we do this, so I wanted to show you, right? So if we have 255.255.0.0, that would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. So it will be like that, right? Now, the question tells me that I need to borrow some bits to make 8 subnets within, right? Let's say that I have a company and now they want to have an additional 8 locations. Okay? So I would ask myself, what would be, how can I yield 8 here, right? So it would be 2 to the power of n is equal to 8. So what is n? So I know that 2 to the second power gives me 4, 2 to the third power, that's going to give me 8, right? So I would know that n is 3. Are you with me so far? Because it's multiple of 2, right? Because it's a base 2. The first power, 2 to the first power is going to give me 2. So now if you want to solve this algebraically, right, you would do natural log of 2. That's going to give you the n value. All right, so this is n is going to be 3. So we know that we're going to borrow 3 bits into the host, right? So this is the original, right? This is the borrow 3 bits. Understand? Any question? Yeah, Dima. Say it again louder. So originally the host, right? You see where my H is highlighted? This host originally is just 0, right? Right. And so if I turn on the front 3 bits, if I borrow into the host, the first 3 bits, you notice that now it becomes the 0, the 3 here becomes the 1. Yeah. So that's how I would be able to have a different subnet. So I borrow the 3 bits from the host ID. And how do I know it's the 3 bits? It's because 2 to the third power gives me 8. And that's the question tells me that I need to create 8 subnets. So my question for you is, let's say that they want not 8, but they want 10. So how do you calculate that? You still would raise 2 to the power of n is equal to 10. You can have extra, right? But you don't need to use it all. Okay. So if I raise 2 to the 4th power, that gives me 16, and I'm using 10 out of 16, that's okay, right? Because there's no like 3.5 in the exponent, right? So if you're asked let's say I need 20 subnets, right? You ask yourself 2 to the power of n is equal to 20. What could be n? And n can be, the result can be larger than what your requirement would be, right? So 2 to the 5th power gives you what? Right? So you just increment your exponent, or you find the value for n, and that the n is going to be the representative of the borrow bits that leads into your host ID. And it's always going to be the front bits, not the back, because that changes the binary value completely. Okay? So we borrow 3 bits, that gives us 8 subnets. That's what the question asks. Then the next step is, remember the 2 questions I said at the beginning? How many networks do you need, and how many hosts do you need per network? Those are the 2 things that's most important, right, in subnetting. So now we're going to calculate the hosts. Okay? So I know that IPv4 has 32 bits. So it's 2 to the 32 power, right? And I need to subtract 2 to the 19, right? Why the 19? So how many bits do you see are ones here? 19. 19, right? 8, right? Plus 8 plus 3 gives you 19. See how when you put it into binary, it's visible, right? So why 2 to the power of 19? Because this represents 255, that's 8 bits. This represents 255, that's another 8 bits, right, from here. And then I borrow 3. So 8 plus 8 is 16, plus 3 is 19. So now I take the original value for the total IP address, right, as a whole, which is 2 to the 32 power. I subtract 2 to the 19th power. You use your scientific calculator for this, right? But remember, I cannot use the 0 and I cannot use the 255, the front and the back. So you have to subtract another 2. Okay. So in my range, I can only use in between the 0 in the front, that's a network address. The 255 at the end, that's a broadcast address. So you have to minus the 2 because those 2 are not usable. So I calculate this, subtract the 2 non-usable address, right? And if you learn how to do exponent subtraction, if the base is the same, you just take the exponent and you subtract, right? So 32 subtract 19. And so that means I have 2 to the 13th power minus 2. And that gives me 8,190 host IP addresses that are usable within each subnet. Okay, you got that? Okay, so you might expect something like this on quiz and exam. Yes, question. Like the right here? This part? This one? In here? Yeah. Okay. So now what we will do is we need to take this, right? And we would say, okay, what would be the IP address? Remember, the IP address is 172. And if you convert 172, this is what you get. Yeah, put in your programmer calculator, right? Or you can do it by hand if you're quick. So I take the first octet, which is 172. This is the binary value. The 14, this is the binary value. And the rest are the zeros, right? So they would get the 0 here. So in combinatorics, in the 3 borrow bits, there are 8 variations, right? Math don't lie, right? Because it would be 2 to the third power, that gives us 8. So there's 8 combinations in how we can use 3 bits. All 0, 0, 0, 1, 0, 1, 0. You just keep switching them, right? Just like combination. 0, 1, 1, 1, 0, 0, 1, 0, 1, right? 1, 1, 0, and 1, 1, 1. Okay. So it's exactly 8 if you count it, right? So I just put this here that we can have 8 variation of how we would borrow the bits. Okay. Now, if we borrow like this, we choose this combination, that's gonna give us 192, right? But if we choose the other combination, your subnet is different. Your subnet mask is different. Okay, so are you following here? You know that you borrow 3 bits, right? Just keep switching the 1 and the 0 in combination. You would have these variations. Yes. Y3. So 2 to the first power gives you 2. 2 to the second power is multiple of 2, so it gives you 4. 4 times 2 is 8, which is the third power, right? 2 to the third power gives you 8. The Y3, because we have to solve this, you have to have 8 subnets. If you need 14 subnet, it will be 2 to the 4th power because there's 16 subnets that we can use. So you always going to find the number of bits by the exponent of the 2. Right? Because 2 to the 3rd power really represents what? It is 2, right? Times 2 times 2, right? Which gives you 8. No, it's not given. They just, what's in black is what's asked. So if they tell you they need 12 subnets, then what's your n? What's 2 to the power of n is equal to 12 or larger? What is n? So if I need 12 subnet, right? What is n? So you would have 2 to the power of n has to be greater or equal, sorry, I have it on. Greater or equal to 12. So you ask yourself, what is n? So I have 2 times 2 times 2, that's already 8. Times another 2, I have 16, right? So 2 to the 4th power gives me 16, and 16 is bigger than 12, so I'm good. So you have that look like, I'm not sure what she just said. Right, so it's okay if you have more than what they require, like I said, right? Your n can yield, your exponent 2 to the n power can yield more subnets than what you would need. You don't want excess, but you don't want under, okay? So your n value is going to give you greater or equal to the number of subnet that you need. Understand? So at this point, right, this is not part of the problem. I'm just giving you an example. I would have 16 here, and 16 is more than what I need, so I'm okay. Right? Okay. All right. Any other question? Okay, so we talked about the variation, so now let's put it in the table. This is the tedious part. Okay, so in TAN, that's the IP address that we're given, right? But 172.14.0.0. And so when we put this into binary, and you can use your programmer calculator. So in the first subnet 1, using this IP that was in our problem, right? You have the same octet. So 172, the second octet is 14, right? You can put the 172 in binary if you want. The third octet is all 0. So we would start with, so the first subnet, your beginning IP would be 0. Okay. So here's my question for you. So let's say that this is my branch 1 subnet, okay? It's 172.14.0.0, branch 1. What's the first usable IP address in the subnet for my router? 172.14.0.1, right? And then if I have a firewall, .2, right? And then, so the last octet here is incrementing until we get to 254, right? We don't use 0, we don't use 255. So your usable address has to be within this range, okay? So in your router, you program this network IP in, and it knows that this is the subnet 1, okay? All right. Next subnet number 2. We're still gonna use 172. Still, we're gonna use the 14, right? Remember, I didn't just put the variation for you to just look at and forget, right? You see the variation? The 000, that's the first subnet. The second variation is 001. That gets plugged into here, right? So when you convert this from binary to decimal, you have 32. Okay. Do you follow that? So I know that I borrow 3 bits and my variations are noted here, right? So the first subnet, they are all 0, and we have this. The second subnet, this will be the second combination for the 3 bits. So it's gonna go into the third octet. Why the third octet? Because this is the host ID that we borrow, right? We borrow into the host. Because we have these are the network, they say the same. Okay, we borrow into the host, so the first 3 bits are going to change in combination throughout. Okay, so if I take this value and plug it into my programmer calculator, it's going to give me 32 here. Okay, and then .0. So in my branch 2, I would have 172.14.32. And the router there with, or the layer 4 switch would be a .1, and so on. Okay? Yes. Right. So depending, yeah, whichever class. So if you're using class C, it's gonna borrow into the last octet. Okay. Yeah. You get that? Right. So if you're using class A, it's, yeah, we're always gonna borrow into the host. So we have 32 here. Then subnet 3, my branch 3, right? That's the next combo, which is 010. The third one, you plug that into here, and that's going to give you 64. Sorry, the magenta comes up really dark, but I don't want to use that one. It's already been used. I guess we're just gonna have to magenta it. Control Z. But yeah, so this is the third combo that you have, right? And when you take this value, 010 and the rest are 0, you plug it into your programmer calculator, you get a 64 for that octet. But as you go, you notice that there's a pattern, right? So in this question, when we build the 8 subnets, if you see there's an increment in one subnet to the next. What's the difference? 32, isn't it? So after a few subnet, you're like, oh, there's a pattern, right? But to convert it mathematically, you would see the next one, the next combo is the fourth combo 011, and that becomes 96. Right? That's the fourth combo in gray there. And then we go to the next one, 100. If you plug this entire thing in, you get 128. The reason why I have you type it in binary so you can visibly see the changes in the binary value, which yields, right, the IP address that we need in each range. Now they make subnet calculator, right? I'm just gonna advise you that subnet calculator is as good as its creator, okay? Some subnet calculator might not be accurate, but there are subnet calculator. You can find apps for it on your phone or your computer. Okay. So we left off at 100, the fourth, right? The fifth combination right here, and then 101, which is the next combination. So you keep you keep changing the combination following that pattern, and you would have 8 subnets that is needed for this particular case. So if I plug in 101 and the rest are 0, I get 160, right? And then I move on to the next one. Okay. So now I would have these ranges to begin with, and I can create DHCP server for them, maybe creating scopes for these subnetworks, configure my router and switches or layer 4 switches with these network IP, right? So that's where you start, and then you'll be able to use them. Any question? You're not clear, something, ask. You don't want to ask now, you want to say after or see me another time, then we can do that as well. So as Patricia mentioned, yes, you will always borrow into your host ID, whichever class that you're using, because your network ID has been maxed with the subnet mask. So I put down here for the example, the branch one, right? You get 172.14.0.1 as your router. Let's say that I have an edge firewall. After it gets routed in, the firewall is going to filter. That's going to be a .2, right? And then my subnet 2 router would be 172.14.32.1, right? And then its firewall or whichever appliance or system, it will be a .2 and so on until you get to 254. Okay. Any question? So that's it. It's not hard, right? It's just, you just need to know how many bits you're borrowing, how many hosts required in each network, and then you would go through and you would create your combinations. Okay, so once we have this, we need to come up with usable addresses. I think this is like the hardest part in networking for most people, but it's not hard. It's just if you understand binary and a little bit of basic math, then you're okay. Okay, are we here okay so far? Any questions? Do you have any concern or questions asked? Oh, you guys are much better than all my other classes. Okay. All right. Now we are going to use the second table to come up with usable addresses. The reason why I had that placed there so that way you can see how to implement this. Do you need to all this lengthy way? No, right? The point is to get to this part and then come up with the usable addresses to be able to assign those to your systems. Statically or dynamically? Okay, the second part. So we're gonna start with the first subnet and then we'll move forward. So you just take the column on the right, the calculation that you have, you bring it down and you change up your host. That's it, right? As I gave you the example, the first usable address is gonna be for the branch 1 or the subnet 1, 172.14.0.1, right? And then subnet 2, because we had changed up this value, that gives us 32 here, and its routers or gateway is gonna be a .1, right? And then so on. So you basically take the column that you had calculated with the network address and you change up to the usable host. You replace the .0 at the end with a .1. And you would start from there, right? I would have a .2 for firewall, .3 for my servers, and so on. So we have the beginning of the usable address. Now we just need to determine the last usable address. Because when you make a scope, remember when you created your DHCP server, you have to put in the start and the end address, right? So what we need to do is we need to find what is the last usable IP. And it's straightforward. So when you look, right, the binary on the 4th octet, that's your host octet. You would go, so I would start with all 0, 0, 0, 1 for the beginning. Then the last one, everything except for the least significant bit are ones. So you have all ones and 0 at the end. It's the opposite to this column, right, which is the start. The end, you notice that they are all ones except for the last bit, which is 0. So you would have 254. Now, this is not always the case. Sometimes you cannot use specific one depending on how you create your subnet, but it's common to have 1 and 254. I cannot use 255 because 255 is a broadcast address, and I cannot use a 0. That's why we subtract the 2 at the beginning. So you basically replace the last octet with the 254 for the ending usable IP in each range. Simple. And if you look at the binary, right, you see it flips the bit. The computer is a calculator. Ultimately, it's just signal on and off, right, as an integrated circuit. So if you start there, the end, it's going to flip the bits. It's going to turn all of the front bit except for the last. And if you convert that into a decimal, you get 254. Any question? So as an engineer, right? Yes, question. So, the last one. Okay. Good catch, right? Nobody saw that except for you. Okay, so Patricia asked, why is this not 32 but 31? You have to remember that it is one less because it goes from the host, which is the 0 at the beginning. There's 32 within an increment. So you go from 0 to 31, right? Because I cannot get to 32 because 32 becomes the next network. Okay. Yeah. It increment by 32 in this octet. You saw that earlier, okay? And that can be confusing. You see this here, right? So I can go from 0 here to 31, right? So this is what we calculated at the beginning, right? I can go from 0 to 31. That's the first subnet. And then 32 becomes the next subnet, 2. Right? This is what we set up earlier, right? So that means that when I get here, I'm going to go from 0 to 31. That's subnet 1. And then 32 to 63, that's subnet 2. Because it can't go to 64. 64 is part of the next subnet, right? And then 64 to 95. So it's one less for each range. Because if you calculate that out, it won't reach the 8,000 that we talked about only using one octet. It has to use 2 octets. Okay, so because each increment is 32, so you go from 0 to 31, right? 32 to 63, 64 to 95, 96 to 127, and so on for each subnet and for this octet. And it's also using this octet. Remember, because there's 2 host octet and 2 network octet. So are we okay with this? Any questions? Now, if you look at the third octet, right, it's simply changing. We talked about how we're borrowing, okay, and that's what we derive for the host. So we're still using the same combination, right? That's what we talked about for the 8 combinations to derive. Okay. Now, if you look at this last one, it can be 255 here in the third octet, but 254 here. As long as it's not 255 here, you're okay. Okay. So this one in particular, sometimes that confuses people. This last usable IP, right? You can have 255 here, but as long as the last host octet is not 255, it's not broadcast. Okay, so each chunk is 32. So that's what we have. So we would have one less for the third octet for the last usable IP. Okay, any question? So the starting address is really easy. The ending address, you subtract 1 on the last octet and you subtract 1, right, for the third octet. Except for this. Because there's no 256. Okay, now we're gonna look at host broadcast address. So as you know, right, we replace the last octet with, for the last usable with 255, because 255 is at the end. It's after the last usable address, the ending usable address, okay? So why cannot be 32 here? Because 32 is not the octet for the last usable. So you look at that column in the previous, right? For subnet 2, it's 31. So you just change the last octet for the last usable IP from 254 to 255, right? And then you would see that, right? So you got to keep this octet from the last usable IP, this third octet. So it's exactly like the last table, except for that we increment the last octet, right? And what by adding 1, so it's 255. And like I said, you cannot have 32 here because 32 belongs to the next group. Okay, so it has to be 31, 64, 95, 127, and so on. So that means that the fourth octet, all the binary, they are all ones, right? And that's how the system knows that it is a broadcast address. It sends to all. Any question? So I put a note that all your host bits are set to 1 on the last octet, so that should be, or the octet that you're working with, because it might be a different class when you do a letter, a different example. Okay, so the task is first determine your network, right? IP for your subnet, then you're gonna go and create the range with usable IP addresses from 1 to 254, depending on the range. Sometimes we would see the changes in the prior octet, right? And then determine your broadcast address. Let me put this table down on the next one. So we see it as a whole. Okay, so now what we're gonna do is we are going to look at the number of addresses, right? We did this calculation at the beginning, okay? So when we put together an IP table for the engineers, right? We would see that the subnet 1, right? Your network address is 172.14.0.0. The first usable, you just pull it from a few tables ago, 172.14.0.1. The last usable, you plug that in, 172.14.31.54. The broadcast, 31.255. And your subnet mask is this. Because it's a CIDR 19, you have 8,190 hosts at IP addresses per subnet.
That still seems like a lot.
Yeah, I mean, but you might have people, companies that are very popular in the global environment, right? And they might have, or if you look at service provider, like communication service providers, they require a lot of IP. So how did I come up with this? 224. What do you think?
Decimal value of 1110000.
Hold on, I know you're typing. This, right? This is you plug this into your programmer calculator and you would get 224.
Okay, so this is what, so if you solve this problem at this point, when you have your IP table completed, and as you see the progression we would start with the number of subnets, the number of host calculation, then we would start with, setting up the IP ranges, right, for each. Starting with your network IP and then progress into usable IP addresses. And then move into your broadcast IP. Then at this point, we would put together our new subnet mask. This is a new subnet mask that we would use for our 8 subnets, right? Now, some switch and router, it doesn't require that you put in the subnet mask. If you put in a /19, especially a lot of Linux servers and systems, they just want a slider. So if you put in /19, it automatically knows that this is your subnet mask. Okay. So now I would be able to have 8,190 system per subnet. And if you take that number and multiply it by 8, you would get a total of usable IPs for all your systems. Now, hopefully this is going to be able to match the scale for 5 years, but by the 3rd year, we look at it again. If you have exponential growth, right, you have to figure out additional subnets that you need to add to this IP address. Then we will start tweaking this again, right? Your CIDR again. So that's basically how we will be able to divide your subnet. Any questions? Okay, you want to do number 3?
So this one is a common one for many networks, even here, right? I've worked quite a few companies, almost all of them, if they require a lot of IP addresses, they normally use class A, and that's a 10 dot. Okay. So for number 3, we look at the IP address, the subnet mask, and you determine if it is a classful address or a classless address. So if it is a default class A, B, C, then it is a classful address. That means that we don't change anything in the subnet mask. It stays exactly like how it was standardized with the table, right? But what you just saw, we did the previous exercise, you change your subnet mask. So it's a custom subnet mask. You use a CIDR, then it is no longer a classful address. It's a classless address. It doesn't belong to its class, right? Because it's borrowing bits, so it's in between, right? So a classless address it's not exactly its own class, right? Like we saw that we started with class B, but then it's borrowing into C in the next octet. So it's not a B class anymore, right? So if you're looking at 3A, if we have this IP address 10.0.0.30, and it uses a subnet mask 255.0.0.0, this is a true class A. So it is a classful address. It belongs to its class A. Okay? But when you look at B, 141.18.0.19, and the subnet mask, this is going to tell us whether it is classless or classful. 255, 255, 248.0. This 248, it's not a 255, right? When you look at this, right? Does it belong to its class? No, right? It is a classless address. Okay. It doesn't match up with your standardized IP classes. And then on the next one, this should be a class C, right? So 204.110.0.193. The subnet mask is 255, 255, 192.0. You already know this 192 changes the game, so it becomes classless address. It should be a class C, but it's not, right? It doesn't belong to a true class C, so it's classless. And then this one is a class A, while looking at the first octet, for 48.255.255.254, the subnet mask is 255.0.0.0. This is a true class A because the subnet mask is how it's defined in the class table for class A. So classful address. Okay? Any question? I recommend you go back and practice. I'm gonna talk about the extra credit workbook that I posted. You just need to do at least 3 exercises from that to get some credit. But I would encourage you to use it to do more. So the more you do it, the easier it gets. And then I'll go over some of the exercises in the future lecture. Okay, next question, number 4. Any question regarding 3 or the prior exercise? No? Okay.
So all those subnets would all have the same mask, they'd all have the same subnet mask. So when we create-
Yes. Yeah, because those 8 subnets, right, was created with that subnet mask.
Okay.
Yeah, with the CIDR.
Okay.
Now, if you want to change from that into, let's say that you grew double the size, right? So now I need 16, so now you need to borrow 4 bits, so you have to change the entire set to that. Or you can also scale, you can add additional and just have it route back.
So if you ever come into the situation where there are subnets set up, but we need more addresses,
Exponentially, yes.
the move is just to create new sub and just.
To add new subnets with subnet mask and have it routed in.
Okay.
It's just like you would treat it as they are external network, but they still belong to you. So that means that your routers just need to be configured to get them routed in. But subnets already been routed in, you know, so. Okay, good question. All right, so now we're gonna need to put the CIDR together, okay? When you get the IP address 10.0.0.30, I use the same one from the prior exercise. Your subnet mask is 255, right? So you can see my calculation, 255 represents the 8 bits that are on here, right? And then the rest are all 0, they are all off, so I would have a CIDR 8/8. And then for the next IP, 141.18.0.19, I look at my subnet mask. I have 255, that's 8, right? Another 255, that's another 8, so 16. And then you can take your programmer calculator. So I open up my calculator, and then if I put in a decimal 248, right? I click at the bin, so that will be, you count up the 1, so 1, 2, 3, 4, 5. So I know that that's a 5-bit. So I add them together, 8 plus 8 plus 5 gives me CIDR 21/21. Really simple. right? So that step again is you take the value here. If it's not 255, you put it into your programmer calculator as a decimal, clicking DEC, and then you click the BIN, the bin for binary, and you count up the ones. That will give me the added bits that are here. So I take 8 bits for the first octet, second 8 bits for the second octet, plus the 5 bits for the 248 that I just converted. That gives me a CIDR 21 when I sum it up. And then same thing for the next one. So the subnet mask is given here. So I have 255 that yields 8 bits. The second 255, that's another 8 bits. And then I take the 192. Let's clear this. Click decimal 192. And then I click the binary. I see that there are 2 bits. So it borrowed 2 bits. So I would add the 2 plus the 0, which gives me CIDR 18. So 8 plus 8 is 16, plus 2 is 18. And answer D is the same as answer A. So you have a classful class A, which gives you a /8 or a CIDR 8. Okay, so that's how you calculate CIDR from the subnet mask. Any question? So I would expect you to know how to do this for final and quiz, the upcoming one. Okay. And then how many bits you're supposed to borrow for a certain subnet amount. Okay, so as you look through the notes, similar to what we have done in our exercises, right? I broke it down just a different example so you can take a look at the 10.IP address compared to the class A compared to class B, and how we are able to derive more hosts in the class A. So as you see, class A actually gives us in the millions versus the thousands. Right? And so you can see, and then it talks about classless and classful on page 3. And this is important when you are dealing with specific protocol for routing. When you're using classless, right, subnet mask, it would use like variable length subnet mask, which is your VLSM to route, as it knows that you don't necessarily have the regular classful subnet mask. It doesn't belong to a specific class. Now, if you're using classful subnet mask, the routing protocol do not need to advertise that information. So you don't have to use VLSN to route. Routers support all of these, but you know, in the case that if you just use a classful address in your network, it doesn't require the advertisement of the mask, which is your CIDR. Okay, and then it talks about classless routing. So basically your packet destination, it would need to match the router's default route. So you have to set route, right? If you're using dynamic route, it needs to update it the first time and refer to it. And if it doesn't match any of the other route, it would then forward that packet to the default route. So my analogy is like this, right? You always default to the freeway to go from home to work, okay? That's the way that you know, okay? However, there are other ways to get from home to work, like inside streets, you know, etc. Okay? So In the classless routing, if all else fail, it's gonna default to the way that it routes in the classful. Okay, so basically it's gonna forward that to the default route if there's no additional information that it uses to route. And so here there's some comparison, but as you can see, right, it only matches based on the default route, but it doesn't match any other routes, then it's gonna use that. So like going to the freeway, even though there's congestion and traffic, regardless, but you can take alternate ways. And so in a network environment, we don't always have to defer to the default route. We can set up routers to behave a certain way so we can have dynamic traffic diversity in our traffic to handle priorities. So that means that you don't just use the default route. You want to have alternate routes, other ways to get around your network in the case of congestion or latency. Okay. And then CIDR, I always call that a CIDR. Everybody calls that a CIDR. It's the slash with the value. So instead of writing out your subnet mask, you just use your slash and a number, your mask bits. Okay. So it talks about how this is used to aggregate what you see as prefixes for interconnected networks, which what we see as the internet. Okay. And then it touches about routing. So we're going to have one unit that focuses specifically on routing, and this is the intro, and I wanted to talk a little bit about it. So in a small network, you would see on the routing table by typing route as a command, your static routing. It's kind of like I said, right? You would get from point A to point B the same way every day, day in, day out, no change. Okay. We would manually put this in and tell the system that it needs to send from router A to router B to router C to router D, and that's how it's going to transfer. Okay. Now, dynamic routes allows the router to be able to make the decision based on its service. So it might go from router A to router D, right? To router C and then the destination. So it's like finding a better way to get from home to work depending on the traffic that day. So once it has the information, it's going to then update the table so that way it can defer to that route as the most efficient for that time or whatever not, right? And we would learn about different type of service. So open shortest path first, it's kind of like how I can get from home to work the quickest, with the shortest distance, okay? If you take computer science, the structure class CIS-7 talks about graphs and route, and in programming, what we do is we actually look at the algorithm so that way we can determine this is the same thing that FedEx, UPS, everybody in logistics center kind of environment use, right? So in communication, open shortest path first is the available system, the available road that you take that is going to get you from point A to point B the quickest. Okay. Now, not all routers supports this or that service is enabled. The older algorithm that you see is routing information protocol, which is RIP, and RIP version 1 has security issues and problems, so it's vulnerable. Even RIP version 2, right? So you see the older routers is using routing information protocol, so it updates each other with its routing information. And then you have EIGRP, we'll expand on this protocol later. So it is a way that because the router acts as a gateway, it allows you to be able to integrate, right, a dynamic way to be able to get your traffic, your packets from one point to another. So there are specific type of service that the routers use. In the world, the internet is basically made up of many autonomous routers, right? Some routers act this way, some routers use this thing, right? So it could be in variation that you would get is what we make as an internet. Okay? So let's talk about distance vector, which is for the next question. So distance vector algorithm, this is also known as Bellman and Ford algorithm. This is going to be designed based on cost. So I do this in a manual way with my discrete structure class where you look at the vector. So let's think of it this way. Your house to the main road is 2 miles, okay? And then from there, the next street is 4 miles. So what we can do is we can put a cost, a numerical value to represent that road or that vector, that path, okay? So from router A to router B, this cost could be 5, right? Router B to router C, the cost could be 11. So how does it really determine? It basically total up, just like how you total up the distance from your home to work in different routes on how Google Maps routes you, right? One way, it would take you 15 minutes, but you would go further. You actually have 2 additional miles. Instead of, let's say, 10 miles, you go 12 miles. Another way, it would take you shorter time because it's less distance in miles. So in the distance vector algorithm, what it does is it basically, each node on the network, it's going to be able to share its cost. And it calculates from the source to the destination based on the sum or the total of the numerical value in the vectors. Then what it's going to do is it's going to determine based on that 12 versus 10 versus 21, etc. Right? So now the way it does it is then it's going to update each other, right? The routers convey that information to the neighbor so that way it would say that here is my dynamic route information and the total cost of it for the distance vector is this. So that way it does a comparison in all the adjacent nodes so that way in case that it repeats it, it can defer to that route table. And this is a dynamic way, and this is what you see as representation in Google Maps, in shipping routes, and all of those things, because it really stems on how we built the distance vector algorithm. Okay? And so when it discover, right, the updates actually is being shared. So if there's a newer path, there's new routers get added and it can get there quicker. So it shares the information. I always say that the routers are nosy, right? Some are nosy neighbors. So basically it updates each other. And that's how you get efficiency in routing, in mapping and graphs. Okay. So let's talk about algorithm for routers, right? 5 types of routing algorithm based on the below scenarios. Nodes send information from point A to point B via the path of the results in the lowest total cost. We just talked about this, right? From home to work, if I go this way, it's going to be less miles total, less total miles. So that's going to be your distance vector algorithm. Total number of miles is the least. So that means that the cost, it doesn't have to be, so each of the distance, basically the node contains, it has a set value, and that is shared as calculation from nodes to node, from router to router. B, to produce its map, each node floods the entire network with information about other nodes that it connect to. This is called linked state algorithm. So basically it broadcasts to the other ones. It says that this is the information I have about my route, right? And it shares its state for linking. It sends the information, so it's called linked state algorithm. And the third one is each border router advertises the destination it can reach to its neighbor router, and this is called path vector algorithm. It's kind of like you found a new way to get from here to Corona, and you share it with your friend or your neighbor, right? Because you found a new road, you found a new path, so this is gonna be your path vector algorithm. Like I said, we will revisit some of this information down the line. You would actually look at like a distance vector where we calculate them to the path. I make my discrete class, they do this in a way from a computer science perspective when they program it just to kind of see how that would yield. But you know now that with AI and analytics, a lot of this, the decision-making process is enhanced, right? When we're looking at communication and routes or even in logistics on how we can, you know, streamline this entire thing to get from here to there. Your packages get shipped quicker, how we can move the trucks, train, plane, and transportation in a different way. So with data, I think, you know, the reason why routings are so successful is because the data are shared, like statistic information is shared between the routers. Autonomous system does that, and hence the term autonomous. It's what you already seen since the 80s that is a component of artificial intelligence. Right? So this is what we see now. Which is cool. Like I really love this part because this makes the world really communicates. You know, without router, you would be no communication. Okay, any question? Okay, so as I mentioned, if you missed it earlier, I will stop right a little bit after this so we can take attendance. There's extra credit opportunity. I know some of you have attended last year for Zeta Sky. They are now part of the apprenticeship program. They hire our apprentices as well. I know this comes up short. I just been so swamped lately. I'm sorry. I also had missed the Cal State San Bernardino open house last week, but when they have another event, I will share that with you. This is gonna be in the city of Fontana. When you get there, it's kind of interesting. It's like there's a little park and then there's a parking lot, and then you would go into it's kind of like a little town center area, and they would hold events there. You will need to register. Usually they probably have like breakfast or snacks or whatever. Sometime a light lunch. FBI will be there, and I think they have speakers. And you will be able to network with local IT professionals and organizations that go there. City of Fontana hosts it, so the majority of their employees will be there. So if you're there, just take a selfie. You don't have to stay the entire time. That's how I can tell. Sometimes I pop in. It starts at 11 this time, so it's gonna go from 11 to 1:30, but don't show up at 1 because sometimes they finish early. Usually they don't. Some of the bigger speakers are gonna be like in the middle or halfway through. So if you want to, I don't know if they're doing deepfake again this year, but FBI did deepfake last year. I will try to pop in halfway through. And then sometime they would have like Threat Locker or one of those security companies. It's always good to bring your digital business card and connect with them via LinkedIn, because you never know, right? You might apply for their company and just have that connection can be important. So that's one option. And then if you are interested in to become, so I'm gonna tell you, okay, based on my experience, a lot of the security things that you do is auditing. Okay. Not too thrilling. Audit is like catching issues and error after the fact. That means you go back, you look at what's happening, what you have, and you fix it. Just like how people audit tax, finance, all of those things. So ISACA has many different types of certification, but the big one is CISA, which is highly demanded in the security world, right? And so they have an event And it's a good way for you to learn about their product, and they have free community training online. So I think we have SACA membership, but not ISACA membership. I have to check. So, and then they have industry people, sometimes they have job opportunity for students. This is a virtual meeting and you can sign up for it. That's on the 7th of November. And then the next one is going to be for NBC Apprenticeship Expo. Rosalinda does a good job. They have a huge event, and this is gonna be at the community center. I think it's at Frederick. It's right near City of Moreno Valley town hall area. There's like a little community center. There's like basketball court, but they have a hall, so you can register. You can go there. There's gonna be business, right? Employers, you know, high school, college students. It's usually a big event. So if you go, you'll be able to talk to some employers there. Like I said, right? When you go to those things, you just need to be prepared. So if you have business card, hand out your business card. If they're saying they're hiring, here's my resume, right? Just be ready. And so you can register for the event. When you go, again, just a selfie, I'm good with that, okay? But for the virtual event, just screenshot that you attended the meeting. So this is just basically opportunities for you to expand your professional career if needed. Okay, any question? Okay. Oh, maybe one more thing I want to talk about. One thing, I want to put this on the recording because in case the students are not here, they wanted to see it. So I put another extra credit opportunity, and this is not going to be due until a couple of weeks from now. For as long as I've been teaching networking, this workbook has been pretty okay. So what it does is if you download and go through it, it has from like, you know, looking at your IP addresses to do binary conversion, to do that, right? So in order to get the extra credit, I don't want you to just do binary conversion and hexadecimal. We already done that. I need you to do 3 completed exercise for subnetting. Okay? So when you look at the subnet exercises, let me see. And later on, when we have time, I'll go over these. Okay. So it walks you through on how to identify network ID and host ID. So it's very useful. So you can go through and you can fill out some of the answers. But if you scroll down to the later part of your exercise, right, it actually walks you through on how to subnet. Some of them already have the answer, so you can follow some example. And instead of the table that I've used, I just use like a smaller table like this. So sometimes that technique can be helpful. So there are some example and problems that you can go through as you know, you want to practice it. So I want you to scroll down and complete some of the exercises, and you can clip them out, screenshot them or whatever. So just like what we did today, identify the class, look at the subnet mask, custom your subnet mask, right? Calculate the number of hosts, calculate the number of host address per, right? And then you would have the ranges. But you can use the table from your assignment, or you can go through and just manually do it. Okay? So I want 3 completed exercise for this, and then you need to answer these questions, and you can submit it, and we will be able to add your extra credit toward your final grade later. Okay,